Okay, let's dive into something you probably didn't expect to connect to your math homework.
Oh, what's that?
Calculus and, well, cow manure. Seriously.
Right. Okay. Yeah, we're doing a deep dive today looking at some source material that actually connects higher level math to, yeah, agriculture, specifically animal
And
waste.
the core idea from the source is using mathematical integration.
Mm-hmm. Integration.
Now, if you're maybe a college student, you know, currently wrestling with differentiation and integration,
Uh-huh. Feeling like it's all just abstract symbols, maybe.
exactly, like what's the point? Well, listen up.
Because our kind of mission today is really tailored for you.
Yeah, we want to show you how these concepts, which might feel really distant right now.
They have surprising, like, concrete, real-world applications.
And here's where it gets really interesting.
Okay.
Our source material explicitly talks about applying mathematical integration to figure out something very specific.
Which is?
The manure output from cattle, specifically cattle raised on silage from agriculture fields.
Wow. Okay, so taking integration, which, fundamentally is about adding things up, accumulating quantities.
Right, over time or across variables.
Yeah. And applying that to measure something as, well, earthy as the amount of waste from animals.
Under particular conditions, too, like being fed silage.
Silage, right, that's the fermented feed, like corn or grass. The source makes a point of that diet being part of the calculation.
It's a fascinating link. Does the source give any clue why integration is the right tool here?
Well, it doesn't spell out the exact formula,
All right.
but the fact it points to integration suggests the whole process, the manure output, isn't just a simple straight line thing.
Ah, so it probably involves variables that change, like maybe feed intake isn't constant or something else.
Exactly. Things that accumulate, factors that fluctuate. That's precisely what integration is built for summing up those changing quantities.
And figuring this out isn't just, an academic
Yeah,
exercise.
no, no, not at all. It's vital stuff.
Yeah.
For managing nutrients on the farm, assessing environmental impact.
Right. Makes that abstract math tool suddenly seem incredibly practical.
It really does. And the source mentions there's a suitable formulation using integration.
A suitable formulation. So it's not just a theoretical link.
Nope. It means people, scientists, maybe agricultural engineers have likely built actual mathematical models.
Using integral calculus to solve this very real-world farming and environmental issue.
Yeah. So for you, if you're learning these tools, it's just a powerful reminder.
That they're designed to tackle complex, practical problems, not just textbook examples.
Precisely.
So let's recap quickly. We took a core calculus concept integration.
Something you might be learning right now.
And based on our source, we saw how it connects directly to a, well, pretty unexpected problem.
Quantifying animal waste in agriculture, it's about as real world as it gets.
It really is a practical application of abstract math.
So maybe the takeaway thought for you, the listener, is this.
As you're learning these mathematical concepts,
Mhm.
integration, differentiation, whatever else,
Yeah, take a second and think. What other problems, maybe everyday things or industry issues, could these tools potentially solve?
even if the connection isn't obvious at first glance.
Right. Where else could the math you're studying be used to measure or model or, predict something useful out there in the world?
Something to think about beyond the homework problems.